Hello, everyone. Hope everyone had a nice day. So my presentation today will be on data exploration and visualization, and specifically related to my recent work on designing a data dashboard with Dash. And I shall explain that to everyone later. First, a little about myself. So I'm Lucy. I'm from Shanghai, China, and my academic journey has been quite a bit of a mix. So I did a bachelor's in experimental psychology back in the UK, where I lived for 3 years, and then I moved to Amsterdam last year to pursue a degree in brain and cognitive sciences, which was a master's research master's. But I have a particular focus in computational neuroscience, basically building computational models of neural networks. My last year, I was working on predictive coding and Hebbian learning, specifically regarding visual representation learning. And at the moment, I'm actually doing my internship at the CWI. It's working on spiking neural networks. So, if anyone's interested in any of those, I'd be happy to connect or chat later. And at Purple Gaze, I am a junior software developer and application developer. So basically, I've been working on Python packages that are supported, that supports the hardware side of eye tracker. And so that's about me. And just a quick sort of outline of what I'll be presenting today. And so the first section would be sort of a discussion of why data exploration and visualization is important. So when I was making this presentation, I realized that how actually commonly this is overlooked. So I wanted to highlight the importance of exploration and visualization. And then I will go through some design principles of data visualization, basically outlining what makes a good, what consists of the good practices of visualization and exploration. And then I'll outline the steps towards building a dashboard. And then at the end, I will showcase specifically the tool that I'd be using to build this dashboard, which is Dash, and sort of giving you a rough idea of how this library works and maybe how you can use this for either your own studies or if ever you want to build a dashboard, how you can utilize this library. And then in the end, we'll have a Q&A just in case you have any questions. And during the presentation, if you have any questions, feel free just to raise your hand and I can address it as we go along. Okay, cool. So the first section, like I said, is on understanding the importance of exploration and visualization. And so just a quick definition of what is actually data visualization and why we need it. So I found this quote online that is actually a really good summary of what it is. So exploratory data analysis refers to the critical process of performing initial investigations on data, so as to discover patterns, to spot anomalies, to test hypotheses, and to check assumptions with the help of summary statistics and graphical representations. And so, as we can see here, it is a crucial step to achieve a rough and intuitive understanding of the data set that you're working with. And it's very important for either data scientists or researchers or anyone who will be working on a data set to achieve this understanding, because it should guide you in the later stages of either data cleaning or even further analysis. And there's some obviously examples of data exploration, such as plotting the distributions, computing the correlations between variables and different measures, and then applying summary statistics, for instance, using mean and variances. So I've given two examples at the bottom as well, sort of showing the what example plots that you can use to sort of visualize or explore your data. And then on the left, obviously, we have a distribution, and on the right, we have actually plotting two distributions on the same map. So, I mean, there are many of such available available summary statistics and plots that we can use. And so, and then just to highlight why we need it. And then there are many pitfalls for not exploring your data first. So for instance, if you have outliers in your data and then you didn't visualize it at first, or you didn't measure it at first, and then it will skew any of the statistical analysis that you end up doing in the end. And then also it could, if you don't understand how the data that you're working with, you might end up using the wrong analytical techniques. So for instance, if, as we all know, in statistics, there are parametric statistical tests, and those statistical tests normally rest on the assumption that, for instance, that the data is normally distributed. And so if your data is actually not normally distributed, and then you end up using a parametric test, that actually makes your test results not the most appropriate. And so it is very important in this case to check all the assumptions of the tests via data exploration. And then also, for instance, if you actually have corrupted data during collection and you don't examine your data files, and then just ends up basically using the data in your population data, for instance, for analysis, that also would affect your results. So it is overall very important to do a sanity check before you start doing your proper analysis. And it's just very important in research settings and even in industry settings. And even so, for instance, in clinical cases, it is just very important. I cannot stress how important it is. And one thing that we should keep in mind is that, so data visualization is often a technique that we use during data exploration, right? So it provides us with the visual intuition and understanding of what data we're working with. And there are often actually two different needs for data visualization. So one, like we said, for exploratory purposes, and normally it's to drive decision making, right? So if, let's say, you need to examine your data distribution, so that you need to decide, okay, which data points I should exclude from my outlier as outliers, or whether I should include the data from this participant in my analysis or not. And so there are often specific cases in which data visualization is serving a specific purpose. And the second need or common need for data visualization is presentation. And in this case, it is rather different, because you're presenting data in a certain way that you're trying to communicate either a message or a point. And so when you're working in this situation, the questions that you should be asking is, what message am I trying to communicate, and who I'm presenting my message to? And so regardless of in which situation or in which context you're operating in and you're trying to do data visualization, it is very important that you understand what your need is for data exploration and visualization, and then choose the appropriate techniques to achieve such goals. And so that's sort of the context of exploration and visualization. And so what are some good design principles of designing data dashboards? And so fundamentally, a dashboard is a visual display of the most important information that is needed to achieve one or more objectives. And it's consolidated and arranged on a single screen so the information can be monitored at a glance. And so, as I've given an example here, where basically oftentimes you'll see these different building blocks on a data dashboard, and each containing a different piece of information. And again, designed based on what your need is and what the context is. And then normally you have 3 components to a dashboard. So you have, or any plot actually. So you have content, context, and construction. And so content obviously is what data and information is being presented. And then context is in the sort of the context in which the data will be interpreted in. And this is rather important because, for instance, if you have one data point extracted from your data, but then oftentimes if you present it without context, this data can be quite meaningless. And so you want to either, for instance, if you're looking at one participant data, maybe you should also present what the mean of the population is, so you understand where this participant lies in the population. This is obviously just one example, but the important thing to keep in mind is that when you're trying to interpret your data, what would make sure to present the context so that your data becomes meaningful. And the third one is data construction. So like kind of the more graphical components and sort of how to present a visually appeasing and informative graph. And then so there's some basic design guidelines, and oftentimes if you're designing a data dashboard for your own use, because obviously not everyone is a designer, but these principles are good to sort of follow. So first is consistency. So you want your some kind of consistency, either color, font, size, scaling between your plots on the same dashboard, so it's just visually clean. Proximity is if you have related data, so like if you're extracting features from the same section or related things, then you want to put them together to facilitate interpretation. And then layout is just simply having a clean layout, don't overcrowd the screen. And so, yeah, like I said, just to reiterate, sort of you want a good dashboard to be clean, intuitive, and also quite customizable, because as we all know, oftentimes in research or industry work, the workflow is not entirely linear. So sometimes we want to add new components or even take out components and adjust and add new information as we collect more data. And so it's quite important to build in sort of that flexibility into your design of the dashboard. For instance, importing data, how you want to read out the data, and what kind of information you want to extract even further down the line. It's quite important to sort of keep those things in mind when you're building up the sort of the structure of a dashboard. And yeah, so you want to communicate information quickly and effectively. You want to have the core information that can be generalized across different contexts or different users. So what that means is that you want to design like panels such that it can be consistently reused between either users or researchers. But then also, yeah, building the flexibility so that for each specific use case, they can customize to their specific demands. Okay, and then furthermore, a lot of the times you will see that actually reduced complexity provides clarity. So make sure that only include the information that is necessary and needed. Prioritize relevance. Goes without saying that relevance is very important, and sort of just outline sort of what design decisions should be guided by. The first thing is the purpose of the dashboard, the nature of the data, and then the need of the users. So all three should contribute to all kinds of decisions that you make when you're building, writing code for this dashboard, not only visually, so how you want to present the dashboard, but also content, what data should be included on the dashboard, and the functionality. So what functions should I build into it and to serve what purpose? And so it's very important to sort of have a clear guidance as to have a clear guidance to how you make these decisions when you're designing the dashboard. And yeah, just to sort of stress what a dashboard is not. So it shouldn't be just a display board with all the available newest graphic types, because oftentimes you see that some designers would like to showcase all the possible like ways of fancy plots that they just want to include in the dashboard. It should be all the things that are included should be informative. And it's not a dumping ground for all statistics that can be extracted from the data. Again, what analysis you do, or like what statistic you extract, should be informative and should help push forward push forward your progression in doing experiments or data collection or whatever need you have. And it should not only be intuitive for the designer, so which means that it should be user-friendly, it should be intuitive to use for anyone outside of the design team. And so, yeah, basically, if you're ever making your own dashboard, or if there's ever a situation that arises where you need to build a dashboard for other people, you should first define who and what for, and then determine what information should be extracted to achieve the goals, decide on the appropriate graphics to display such information, and make sure that the display is user-friendly, intuitive, so that we have a very pleasant product to work with at the end. Is there any questions so far? All good? Cool. Okay. And so I think next I will jump into sort of introducing the tool I've been using to build these dashboards, which is the Dash library. So Dash is a sort of an original low-code framework for rapidly building data apps in Python, a bunch of different languages. So I've been using Python because that's compatible with the data Purple Gates packages that we have. And so sort of slightly on the technical side, the backend pipeline is sort of a React to Python toolchain that they have built. And React is, in case you don't know, a JavaScript library for building interactive user interfaces. And then it's also built on Plotly, which is an open source graphing library for interactive plots. So like actually more common or maybe more well-known library is called Matplotlib. I'm sure that most people here have used it. So Plotly gives you the sort of the interactive functionality that you can use to do for data visualization. And so it's kind of yeah. So if you want to build interactive plots, Plotly is a good library to use. And then basically this allows these libraries and tools together allows you to build a web browser-based data apps. And so that's Dash. And so kind of what I wanted to do was to sort of introduce you to the core things that are relevant to building a Dash-based data app in the web browser, so that hopefully after today's session, you can just go ahead and be able to navigate the Dash documentation a lot easier. So kind of understanding how the library is built and sort of what functionalities it have. And so the first sort of brief introduction, again, so in case you haven't worked with HTML, so it's a standard markup language for creating web pages because the dashboard is built, well, it's HTML based. And so it basically describes the structure of a web page and then consists of different elements that you can specify. And then these elements tell the browser how to display or like render the web, the content. And basically, yeah, it tells different labels, different labels tells the browser how to differently render the components. And so kind of an example here, yeah, so on the right, you can see that this is basically can you see my cursor?
Yep.
Okay, nice. Yeah, so on the right here, you can see that this is the HTML source code. And basically, it's a sort of a hierarchical nested structure in which you have the heads, you have the body, and then within the body, you can have different headings, divs, which is just a section, or even within further, like in these divs, you can have sub divs, and then like, so it really depends on how complicated you want to be building your HTML. But then over here, it's a very simple case where, so I have the head, I have the body, and then I have a heading, which is, it displayed in a larger font. And then I have a div, which is a separate class that is this is a different font. So basically, yeah, so this is kind of how HTML code is structured. So you have these hierarchically nested different elements. And then so that leads us on to these Dash core components. So basically the nice thing about Dash is that it has these built-in core components that are interactive. So you can already use these components to directly as HTML elements and add it to your code and your dashboard, and then it'll just show up as interactive components in your code in your data app. And I'll explain later how more in detail in actual code, but basically by specifying this drop down element, and then when you run the web page, you get this drop down bar thing that you can use already. And then for instance, also a slider, so you just specify the slider component, and then you have a slider that you can use. So basically, this is a whole library of core components you can directly use, which is very convenient. And I'll use the dashboard I'll be building later to further illustrate. And so once you have these components, once you have these elements, you can design a layout that puts these different components together. And so this is an example of from the Dash library, which is just like one of the dashboards they built. And what you can see here is that what they've done is that they have this graph here, and then that is put in this column that is nested in this row, and then that is aligned with other components on the graph. So basically, what they did was, like you design a layout by, you can define it via rows and columns, and then you put the appropriate graphs in the appropriate slot on the screen. And basically, this the library also allows you to design different alignments and then different layouts in this way. So that's super easy to use. But the core idea is that once you have these components and elements, you can lay them out in a specific way that is also facilitated by the library. And then, so once we have the elements, and then we can also add in the plots as HTML elements or components. And so if you haven't used Plotly, it's also super easy to use. It's very similar to Matplotlib. Basically, you have your data, and then you can just put it, call, for instance, a bar graph, and then you put in the data. You specify the X and Y axes, and it just gives you an interactive plot. Again, I'll showcase the interactive component later. This is just a screenshot. And then the last core component, or like the last core thing about using Dash are these callback functions. So basically what they do is that these functions are automatically called by Dash whenever an input component property change in order to update some property in another component. So what that means is that, for instance, you have you want to be able to visualize different participants, like the data from different participants. And then you would, so you want to select, for instance, the participant ID. So you would have a callback function where the output would be the plots, and then the input would be the participant ID. And then the function basically would specify how the plot will be updated. For instance, new data should be read, or like layout should be changed, or etc. So it can be a wide range of things, but then the core idea is that basically it's whenever something changes, I update a different plot or area on my data app. And if you want to make things slightly fancier, there's the CSS code, which is the language that we use to style HTML document. So this is quite like, if you want to sort of have a visual identity, especially like for a specific app you're building, then you would need to use CSS, because that's where the styling comes in. Yeah, so that's but that's like a separate thing from building the app alone. I wouldn't go too much in detail later for this, but just so that it's a sort of I present to you the whole package of how things work. Yeah, so like an example of what CSS file like would look like is that, for instance, over here, that's like basically the code that is specifying how this header over here is being displayed. And yeah, so there's a lot of ways that you can display this. Basically, you specify different properties for each criteria. And so that's sort of the presentation side of things. And then now I want to show you sort of how everything comes together, how everything I presented comes together in the dashboard that we've been developing internally for our customers. And so just, can you see my screen?
Mm-hmm. Yep.
Nice. Okay. Yeah, so this is the dashboard that we have been building so far. So we have different sections. It's still very much under development, but we have a first section, for instance, that is the gaze points per screen, and we have a slider for. So this would be one of the examples of the interactive component that I introduced earlier for Dash. And so the slider allows you to scroll through the different screens of the experiment, and you can see how the data points or the gaze points that have been collected for that experiment screen are scattered across the screen. And so it's a very intuitive and nice way of visualizing how like the quality, like a very direct visual expression of where the participants are looking at and whether your data is good or not. Because, for instance, if the data points are all outside of the screen, then you know either collaboration or some data collection process is wrong. And so that's the first thing. And then we also have this pupil size metric over here, where you can either increase in inspect a specific section of the timeline across the entire experiment. And then obviously you can see here that you can, there's marks of where, again, on which screen this data is collected. And then these are all single time step data points. So again, it's a very intuitive and direct way of interacting with the data and then being able to see what data has been collected. And then, like I said earlier on, you can sort of choose the participants here. So over here, like I've been, you can either do multi-select or single select. I'm in the process of changing this. So this is at the moment slightly buggy, but the idea is that you're able to either add different traces for the participants or just look at single participants. And that basically concludes my presentation. Hope that was to some extent useful. But yeah, thank you so much.